Welcome to springlib.
This is the answer to Chapter 31, problem number 20 from the Smith Organic Chemistry textbook. And in this problem, we're asked to draw a stepwise mechanism for step 2 in figure 31.7 using aluminum trichloride as the Lewis acid catalyst. And so I will go ahead and do that. So we're starting from here, and we have our aluminum trichloride. The lone pair, one of the lone pairs on this oxygen, is going to grab the aluminum of the aluminum trichloride, and so that will take us to here. So this oxygen now has a positive charge on it. It has 3 bonds. And so what will happen in order to alleviate that charge, the oxygen will leave. So the electrons of this bond will revert to the oxygen will take off, and we will get to this point. With a carbocation here. And so remember, this is not just a primary carbocation. This is actually a benzylic carbocation. And so that's really the only reason that this works. Benzylic carbocations are relatively quite stable because of all the resonance from the double bonds in the aromatic ring. So what can happen here now is this carbocation can be attacked by the electrons of one of these double bonds. So that's going to look like this. So that gets us to here. We'll draw this hydrogen in there, and then of course there is a carbocation there from the other carbon that was formerly part of the double bond, and the aluminum trichloride hydroxide species that we made earlier is still floating around up here. So let me draw that a little differently. So what can actually happen is this. So the electrons of that bond can grab this hydrogen. The electrons from the carbon-hydrogen bond can go to reform the double bond as I've drawn it, which would remake aromaticity. So there's a strong driving force in order for that to happen. And so that gets us to our final product. So we've reformed that double bond. And there's our final product. And of course, we also have reformed our Lewis acid catalyst, and we have some water floating about. Yeah. And so that's the answer to chapter 31, problem number 20 from the Smith Organic Chemistry textbook.